Hello, everybody. Good morning, good evening, good afternoon, and welcome to Going Meta, Season 2, Episode number 7. Today's topic is Enhancing LLM Tool Calling with Ontologies. First and foremost, hi, Jesus. How are you doing today? And you are somewhere else than usual.
That's right. Unusual location. So yes, I'm in. I hope you can hear me all right, because in my unusual place, I'm in an unusual environment.
No.
So I'm in Copenhagen for the Graph Summit, and I've just actually escaped to the hotel room to run this session and run back to meet the people at the end of the workshop. So yeah, that's actually on the anecdote chapter. I've had one of those enforced kind of OS updates that our security team. and it just happened. When would it happen? Well, of course, 10 minutes before a live stream. So there you go. So that's just throwing it in there in case some of the demos or some of the stuff goes in a slightly unexpected ways. But there you go. So that's added to the unusual situation. There you go.
It's not what you want. Not ideal. Obviously, your blood is now pumping, I guess, and you're a bit of a adrenaline high. So hopefully all is well. How was before?
I was going to say that this is a friendly crowd, so if we get things wrong, we'll fix it. So, but yeah, so that's good.
yeah. I mean, that's the nice thing. Also, if we see questions from previous episodes, I think we've seen something going way back into episode 4 or 5 or something a couple of days ago, where somebody was, hey, this is no something that is no longer working. We're still looking at it. So obviously, if you need to let us know if it's something that is no longer working, and we can try to fix it and see that we give at least an answer of what could be a next step because obviously now that we're doing this for quite a while, things have changed. Maybe some of these systems we talked about are no longer available, or have changed in a way that this is not reproducible than the way we had it initially showed. So if something's changing, please let us know in the comments to the respective episode, and we can investigate or let us know generally in the comments about the episode.
I was going to say that this is actually a very good point, because you're right. I mean, some of the the frameworks that we use. I mean, we're going to be using LangChain today, and the versions keep coming, of course, and some of the stuff that we've published is a few months, if not years old. So keep in mind that some of that we don't really actively maintain that. I mean, some of them exceptionally when we revisit them, but yeah, that's something that you have to to understand. I mean, it's a very fast changing environment, and some of those, I guess the important thing is, since we have the recording and we have the I mean, you catch the idea, and hopefully it should not be too hard to adjust or to update to the most recent releases. So
yeah, exactly. So keep that in mind. We have lots of episodes in the past, so if something is interesting to you, then check out the previous episodes. There's always a link in the video description. You can find them all there. They are collected in one long playlist now. So that's hopefully interesting. And as always, if you have a topic that is interesting and you think, oh, this would be a good episode, or this would be a good topic to cover in a Going Meta episode in the future, let us know. Again, best place would be the YouTube comments, but you can reach us on all other channels as well, and ping us there. Ping me on Discord, ping me on Blue Sky or LinkedIn, and I can make sure that we collect your feedback and your input for a future episode. Obviously, it's always nice if you give it a thumbs up and subscribe to the channel on YouTube. That helps us a great deal for assessing the need, or not really the need, I guess, that you like it.
absolutely,
that you enjoy the content.
We love to hear that people like what we do. That's
exactly.
always welcome.
Absolutely, yeah. So I think with that we can dive in with today's episode, so that you are maybe make it in time to get back to the finishing minutes of the Graph Summit in Copenhagen.
Exactly.
And as I said before, the episode's title is Enhancing LLM Tool Calling with Ontology. So I guess we start as usual. You have a couple of slides ready.
That's right. That's right. Let me try to find them because I had my my usual slides. Give me just 1 second. Here we go. Going meta. And it's just in the other tab here. So okay, yeah, you're totally right. So we're going to open with some slides. I'm going to explain what we are planning to cover today, and then we'll jump into the code, and yeah, we'll take questions if there's any. So let me start by yeah, maybe before I start sharing the code, let me go on. Well, let me share my screen.
Yep.
Let's share these. That's the tab. If I go, I don't know if you can see that. If I go in slideshow, does it show in nicely?
Yep. That
Brilliant.
works. Yes, perfect.
Okay,
The tab
perfect.
is
So
too long for the slides.
oh, it doesn't fit. Oh, there you go. So yeah, why is that? I mean,
but that's
maybe
all
I
right.
can.
It's all right.
Maybe I can. What if I narrow it like that? Does it adjust? It doesn't work. Anyway, yeah, I was actually on the
it's all right.
title.
Don't worry about it.
I was getting.
I can make it a little bit here. Here we go.
Now
That works.
that's perfect. So no, I was going to say that on the title, I was getting a buzzword warning from Tomas Brattonich. He was telling me, "Hey, are you trying to squeeze as many buzzwords as you can on your title?" And you're right. I mean, these are some hot topics, but it's I mean, we try to be as precise as we can in what we or what we're going to do basically. And yes, we're going to talk briefly about what LLM tool calling is. And then we're going to try to twist it as we always do, and drive it, basically make it dynamic, and that's how we're planning to enhance it using ontologies. So I'm going to well, let me get into the details, and we'll explain what I mean. So that's yeah. Let's open by sharing a simple diagram that explains the idea of tool calling. So. If you've been following us, you know that we've been talking a lot about retrieval augmented generation, RAG, graph RAG, which is a form of grounding LLMs. So we need to provide the LLMs with ways to basically be aware of information that's not part of their training data, right? So that's basically the idea, and RAG is one of the ways. So basically, as we pass the request in the in the context window, we attach to our request some relevant information that we retrieve from, in our case, from a knowledge graph in Neo4j, but it can be from any source, right? So that's one of the approaches that we've been talking more about. There's another one that's called tool calling, right? So this is a different one, and that's what we described. Well, I've taken the diagram from LangChain, but effectively what happens is that there's a typically tool calling is offering the LLM a collection of tools, functions, if you want, that it can use whenever it considers it's right. And that will make it possible to access APIs, to access databases, to interact with the environment, right? So it's a similar but different to what we do with RAG. And there's a step where we kind of offline define the tools, and we bind them to the model. And some models support that, not all of them, but more and more are offering support for tool calling. And once we have the tool called the tool bound to the model, whenever the model receives a request, it will try to figure out if any of the available tools can help completing that task. And eventually, the LLM will generate a call, basically an invocation of a tool that might involve calling, querying a database. That's what we're going to do in this case. But it could be querying a web API to get, the weather in a particular location, or to get the current stock, valuation or something. But that's the idea. So it's a way of, in real time, as part of in the retrieval phase, we're going to invoke a function. We're going to use a tool. We're going to retrieve the information, and we're going to make it part of the output. Does that make sense?
It does. It's just because you said we are not stuffing enough buzzwords into our Is it different to agentic AI, or is this an example of agentic AI? Because this is yet another buzzword that everybody talks about these days.
Yeah, I mean, agents is defined in many different ways, but yeah, basically agents, can have ways of interacting with the environment, not just to retrieve information, but also to act. And tools would be a way of doing it, right? So that can be a valid implementation of the idea of an agent. So we're going to take a very basic approach. And so in terms of comparing it, it's true that because we've always used Neo4j, Neo4j, a knowledge graph built on Neo4j as the retrieval or as the kind of the grounding partner of the LLM, we're kind of used to get real-time information from the database. So from some people might be saying, hey, that's exactly what we do in RAG. And in a way, you're right, but you have to think of these in a different context. So some people are using vector databases, for example, as RAG, as grounding partners. So, and typically in vector databases, what you do is you take unstructured data like PDFs, like diagrams, like documents, you chunk them, you put them in a vector, you index them, and you can retrieve information from there. And that tends to be a more sort of if not static, at least slow changing data set. So yes, you go and retrieve which are the relevant bits of the documents that are valid for to answer your question, but you don't think of that as a real-time query on a live database. In our case we do, and we're sort of spoiled in that sense because Neo4j supports vector, vector index, vector search, and then contextualization, and it happens to be a transactional database, so it's always live, and what you're doing is exactly that. But think of it in that context. If what you have is a collection of sort of close to static documents, maybe having tools to complete that is a way of injecting something close to live data or live information, right? So that's where the difference lies. Although in our case, like I say, you're going to think, well, that's very similar. Does that make sense?
Yeah, I think it does make sense. I think there's another good comment also in chat from David. And David says, LangChain has decided to go with the term tool calling, whereas others might use function calling.
Correct.
Which
yeah. Actually,
the same thing.
Yeah, totally. So
it's a lot of terms floating around of these similar concepts or similar ideas that are more or less meaning the same things in the end. So yeah, good point,
that's
David.
exactly.
Tool calling, function calling,
exactly these are
catch-all term.
Synonyms, correct? Yeah, and yes, you're right. I mean, this diagram, if you Google tool calling and LangChain, you'll get to a page that contains these diagrams. So okay, so we understand what that is, and I was gonna kind of introduce what comes next, but let me show you what that looks like, right? So a very simple implementation, and I'm going with I don't try to be canonical in any way with my code. As you know, I write code, but it's more for demonstration purposes here. So let me show you what the definition of a function and the usage of a function can look like. And I'm going to use a data set that you might remember if you've been following us. And let me let's skip this one. And this is the data set that I'm going to be using. This was used in episode 23. And it's it seems to like art because we tend to use that a lot. But it's an extract, a public extract from the Tate catalog. So there's it's a combination of structured and less structured data. So there's a CSV that was published by, I think Tate Modern themselves published it at some point. So it's a CSV, and it was all in chapter 23. And then we extracted some information from the website that complements the catalog. And like I say, if we actually I can share that, because at the moment, let me stop sharing this, and I'm going to try to share the whole window, and like this, maybe it's going to be better. So this is what can you see now? Is that still the same, but maybe? So if I go to going meta, do you see it?
Yeah.
Perfect. So yeah, that was, like I was saying, is episode 23, where we talked about advanced RAG patterns. So if you go there, you will find in the data, well, you don't really need to go to data, but in the data, you have exactly that. So you have the collection as a CSV file, so the Tate collection. There's additional information stored as JSON. That's the one that we retrieved from the website. And there was even a taxonomy that classified the topics in there. But what's interesting, what I'm going to use is directly the cipher, which is the art gallery art graph creation. So if you take this code, and that's what I've done, and run it, you see that it will go and load the JSON bit that's published here, and then the CSV part, and even the taxonomy. So that does it all for you. So I won't spend a lot of time here. What you will see is this graph that I'm going to share with you. And I'm going to, again, stop sharing here. I'm making your life hard, Alexander, by stopping sharing. And I don't know what would be the best way, because if I put this in a separate window, and maybe I'm going to share the whole desktop, right? Might be an easier thing.
It depends how much you're juggling between windows. It might be easier to do it.
But because I'm not in my desktop, it's a bit strange.
Exactly.
Let's try.
So whatever works for today, I think
so,
it's going to be all right.
Do you see my desktop? And that might be, let me close these. Maybe we can close all the history. So this is I'm working locally. So this is my Neo4j desktop. Let's make it a bit bigger, maybe. Tell me. But you see some familiar elements. So if we click on, for example, some, I don't know, artists, we can make it a bit bigger. So we'll have nodes that represent artists from this catalog. If I expand it, we will find, well, we just picked an artwork with, is it with no title, or because we're using the wrong, so there should be a title property?
It should be, but it's
maybe
modern
there's
art, so who knows?
Yeah, it has no title. Well, I picked
That's
well, let's take another one. I mean, sometimes things, there you go, that looks better. So there's another painter here. So that's Henry Moore, and yeah, he's here, or he's connected in this case to a collection of artworks that have a bunch of information that's retrieved from the data set. So have a look at the cipher that generates this graph, but I won't spend too much time on it. Basically, we have this database, and then these artworks have a collection of topics, like we said before. So things that are kind of mentioned are depicted in that artwork. Like, for example, there's people, there's a bone, there's a woman, there's a figure, there's a body, things like that come from this information that we got. Actually, I believe I have to run an additional step here, because hang on, let me make sure that if we go to artists, let's make sure that the names are correct. If I return the n name, yeah, that looks good. No, that's perfect. So we have the names of the artist in the way that I expected. So okay, that's the graph that we have, right? And I was going to say that we're going to now jump into the code to see some definition of tools. Is that readable? Should I make it a bit bigger?
I think that's okay, but if you can make it, yeah, that's perfect. No,
let's remove that part here. Anyway, let's go quickly over the code, and it's a very simple definition here. So I'm using the LangChain tool definition, and as always, I'm defining my credentials to access my local database. So in this case, I'm accessing locally using Bolt protocol, using my credentials, Neo4j, and my password. I'm specifying the database that I'm using, which is called art. I don't know if it was visible here, but I'm using the art database. So that's the name, just to make it clear. And then I define a bunch of tools. I mean, actually, a couple of them, but let's focus just on one, because it's a pretty straightforward definition, as you're going to see. So a tool is a function. And what's important about a tool is that we provide a good description of what it does, because this description is going to be critical for the LLM to figure out when to invoke it. So the description is, this is a function that, given an artist's name, it will retrieve all the artwork, the titles of the artworks that for a given artist, right? So, and I provide a simple cipher query that, as you can imagine, given an author, an artist's name, and I can copy that and show you what that would look like. So if I take that and pass an artist's name, like let's get yet another one from here, this William Blake. So that was easy enough to, let's copy it. If I put it here in the parameter, actually, I'm going to paste it like that. I have to put it between quotes. That should return the list of artworks that hopefully are the ones in the nodes around it, right? So it's simple query. So if you give me an author's, an artist's name, I'll give you the list of their works, right? So that's what my method does. And what it's going to do, I mean, the content of my function is, okay, go connect to the Neo4j instance, for which I've created a driver, like you saw, and run a query, this basic query, passing as parameter the artist's name, and that's it, right? So what's interesting is this function is defined. I'm using this decorator, the tool, to indicate that this is a tool definition. And I'll define another one. It's a bit silly one. I'll show it in a minute. But what's important is that later on, when I connect to my preferred LLM, in this case is OpenAI, I'm going to provide it. I'm going to initialize it with the list of tools. I've shown you the get artist works. There's another one that I call search topic, which is a very simple search and silly search. I'm not even going to use that one, but it's just a way to show that you can define multiple functions. So with these tools, which are functions, I'm initializing my agent, right? So you were saying, is this an agent? Well, LangChain calls it an agent, so good enough, right? So yeah, I pass this set of functions and I specify the behavior of the agent. In this case, it's 0 shots. So I won't go too much into the details, but feel free to have a look at the LangChain's documentation. And I put it verbose because I want to see what's going on. And you're going to see when I invoke it that it's very detailed about what's going on. So that's it. So I've initialized my agent, basically my interaction with the LLM. And what I'm going to do is create a chatbot. I'm going to say, hey, talk to me, blah, blah, blah. And I'm going to enter into a loop of conversation until I enter exit or quit, and that's going to be over, right? So if I run this, and like I say, it's going to be a bit verbose, but if we ignore the initialization, is it readable down here? Can you see the user? So it's telling me, as I was saying, well, can I make
let me
this?
see if I can.
I don't know if I can make this a
change
bit
the layout
bigger.
here a little bit.
It's not very nice, but yeah, I didn't create a nice UI, but I thought I wanted to focus more on the on the logic of it than in the presentation. But basically, I'm going to say, hey, can you list some works by, what was the name of the guy here, the artist there? William Blake. By William Blake. And the agent will figure out, okay, it looks like well, it's all very quick, but basically it's telling me, and this is the kind of log information that I'm getting because I set it to verbose. It's telling me, okay, I've identified the action get artist works as a relevant one, right? And it's telling me I should get the artist. So it's a comment indicating that that's what it has to do. And the input that it's passing to this action. And it, of course, is going to return a bunch of artworks created, right? So basically what the database is returning us. And then it's going to use that to provide the answer. And the final answer is some works. So it puts it in a nice way, in like kind of a natural language. Some works by William Blake include the blah, 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 the agony in the garden, etc., etc. So like I say, in a way, quite similar to what we achieved with RAG, but this is fundamentally different. In one particular way, is that we're not kind of actively going out and passing it as context. We're given a tool, we're giving to the LLM, and it's the LLM which is deciding, maybe the question that you're asking, can be answered with this tool, right? So I can maybe ask another question. I believe David Hockney is also the in the database. So yeah, it identifies it, I don't know, and it gets a collection of, so again, it's used the same action. So it's deciding just as a test. And I don't think I have something in the Tate Modern, but let's give it a try. and probably it's going to fail. It's going to, I don't know what way this is going to be. This is the kind of thing I shouldn't be doing live, but anyway, it was too tempting. So probably it's not returning anything. It's probably going to retry, maybe use the other tool, or maybe just hang, as it shouldn't be, but there you go. Well, anyway, that's looks
no
like
artworks found. Yeah.
So it says, yeah, no artworks found, and it seems like Rafa does not have any artworks in the database, which kind of fair enough. That's what we expected. So good. Anyway, so let's quit. I think that's what the word we're using. So that's great. So that's what we wanted. So we have a simple way. And again, I've not discovered anything here. I just followed the documentation and created a simple. Where is my Where did I put? Here we go. That's my slides. So we can define these tools, and in a way, the problem is like what we had with GraphRag. Remember? So we kind of feel like we're sort of hard coding a little bit what's going on here. So I have to go in the code and put my query. But what if that changes? What if I want to add the option to dynamically define tools without having to go and get the code? And we did something like that in with RAG and show how you could put part of that logic in an ontology in the graph, and that's exactly what I'm going to do now. So what I'm going to say is, what if I take my ontology, the ontology that defines my my graph? In this case, well, it's a simple one because I'm using a very simple description of the ontology. It's just in Neo4j. So I have the notion of an artwork, that's a class created by an artist, like we saw, and has a subject. And then we didn't look at that, but there's a kind of a taxonomy between subjects. So you can have a sort of a broader than taxonomy between subjects, but that's basically the three types of entities that we have in the graph. And what I'm doing is, okay, I'm going to extend my ontology, and I've defined, I'm not going to go today into the OWL RDFS definition because it would take too much time, but what I'm going to do is annotate my ontology and create the notion of a tool, right? This is a screen capture, but I'm going to show that to you in a minute. And basically in my tool that I associate with the class, so if you, for example, for artists, I have a couple of tools, but I could have a couple of tools for subjects and a couple of them for artwork, so, or a collection of them. But the difference here is that I'm entering them in my graph. So I'm describing them declaratively. I'm saying, well, there's a new tool that contains, in this case, a Cypher query, but we could define different types of logic and be more or less declarative. And I provide a description. Remember that was critical. I don't know if it's readable here, but we're going to see it in a minute. So essentially what I'm doing is kind of flipping the thing. And now, instead of me going to the code and writing tool by tool, what I'm going to ask my code is go a little bit meta and say, go look at the ontology, find if there's any tool definitions, and define dynamically tools based on the description that comes from the graph, from the ontology. Make sense?
Yeah.
Cool. So that's exactly what we want to do. So if I go to the graph, and I'll share the code with you as always, but where is my Neo4j? I think it's here. There we go. So if you look at it, we have already the classes. I've preloaded that, but I can show that to you. So if I click on my classes, we see that there's the three entities, subject. If I expand them, you see that the artist is connected to the artwork is connected to the subject. So I'm going to make it a bit smaller so that it fits, even take the whole screen, so it's more readable. So that's pretty much it. Then there's the taxonomy of subjects. So these are connected to each other through the broader than. But what I've done is I've created a couple of tools, and that's exactly what I was describing before, right? So this is the, let me show it here. So I have exactly the same information that was needed, and here I can be richer and I can keep extending the ontology. In this case, I've defined some cipher-backed type of tools, but you could define richer ones. And that's what we do here. So this is exactly the one that we were describing before. So retrieve all artworks for a given artist name, and that's the cipher that we were using before. And I've created another one that, given it's like you can read the description here, retrieve the artist that most frequently uses a particular topic. So, for example, I'm interested in painters that use England as an inspiration, and they, I don't know, landscapes of England or whatever, right? So based on that, I want to get the artist that mentioned that. And you could think of extending this collection of tools as much as you like, right? So it's, again, we're giving hints to the LLM on how to achieve certain tasks. And these can be dynamically augmented by just adding nodes to my graph. Or if we want to talk from an ontology point of view, by annotating my ontology with additional tool definitions. Does that make sense?
Yeah, it does make a lot of sense.
I won't go too much into the details of the code, but basically you can think of it as kind of a meta approach of what we just did. So instead of hard coding the tool definition, let's look at from the end. What we're going to do is a first step where we're going to be loading the tools from the ontology. And that's simply a query to the graph. So I'm going to go to my graph. As long as my graph contains a collection of tool definitions annotating my ontology, I'm going to be able to retrieve them. So what's great about this approach is that it will work as well as it's working now, as long as you provide an ontology on top of your graph annotated with some tools, if you follow this kind of tool ontology that I've sort of created. So this retrieves the ontology. If I look at that, it's a very simple query that basically finds the tools associated with the classes. And for each one of them, it goes, I can comment this one out. But basically, for each of the tool definition, and there's a print here that I'm going to, sorry, that's my debugging dirty code. But anyway, so I iterate over the tool definitions, and for each one of them, I create a tool from that configuration, right? So, and the creating the tool does exactly what I was doing before, but in a kind of a dynamic way. So I'm creating the model based on the input parameters, and ultimately what I'm going to do is, like I did before, creating the tools, and I'm going to register them. Let's go back till the end. So for each, you do it here. So we create the connection to our preferred LLM, and we initialize the agent pretty much like we did before with the tools that has been created. The difference here is that you didn't see in my code any bit of cipher. It's all retrieved from the ontology that lives in the graph. And then, just like I did before, I defined the strategy for my agent and the verbose because I want to see what's happening. Does that make sense?
Yeah, it's good idea, good approach. Yeah,
like and that. Then this is exactly the same. So I'm going to say hello and go into a conversational loop to do exactly the same. I'm going to clear the output here, and I'm going to now run this second dynamic version of my so the usual verbose initialization, but ultimately I get the how can I help today, and I'm going to do something very similar. So I'm going to come here, let's hide my ontology, and let's pick, for example, let's take another one different to the one we used before. Let's now search by subject. So if I actually, if I expand UK cities, maybe I get, oh, there you go. No, that's, I think there was one, let me look at one that was where the subject property is called, no, the artist, so the subject is name, where n.name contains, I think it was about England, right? There you go. Oh, so there's a bunch of topics in the Tate Modern that's about England, but if we take this one, we see that there's a bunch of artworks that actually are about England. For example, this thing by Francis Holman, blah blah blah. That actually, well, it will describe a dockyard at Wapping, right, which is probably a place in England. Anyway, so this is annotated from the database, but I'm going to do something like that. So as we saw, there's a tool defined where I say I can get artists by the most frequently topic they use, right? So that's something that's, oops, I'm got wrong window. Here we go. We're back here. So maybe I can ask something like, which artist use England as inspiration for their works. And hopefully the agent is going to, there you go, it's identified that there's a tool that's useful for that, get artist by subject, which again,
nice.
I didn't hard code, but it was defined in my ontology, and it's passing England as a parameter. What the query does, I mean, we didn't go a lot into the details, but I can show you. If you take it, this is the query. Actually, I'm going to do show all. Actually, I could copy it here. Look what for the expert savvy in the room, what we're doing is, look at that. So we're matching. So the pattern is we have an artist, have artworks created by the artist, and then the artworks have subjects. So that's my entry point. I'm looking for things that use England as its subject. And then what I'm doing, if you look at it, is I'm aggregating. I'm finding the ones that most often I'm doing a count, a simple count, indicating the number of artworks that a particular artist has about that particular topic or that particular subject. And then I take the top 5. So that's what my query is doing, right? And that's exactly what and again, I keep going back to the document. So what this returns, as you can see here, is, well, John Constable with a total of 9, actually William Joseph Muller, William Turner with 29, and then like this, you get this list of top 5. And then, well, the agent says, okay, I know the final answer, and the final answer is the top one is Turner, that actually has 29 artworks. So there you go. So now what's powerful here, again, as I was saying, and I'll stop sharing code here, is that nothing stops me from going to my database and keep adding tools here, right? So the way I've done it is I define it in my ontology. You know that I'm a fan of defining that in things like Protege or something like that, and then import it into Neo. But if you're not a fan of that, all you have to do is, okay, I'm going to create a new node of type tool. I'm going to pass the Cypher query, the description and the name, and automatically that's going to pick up a new tool dynamically without having to recompile my code, or the agent will pick up the available tools and will use them to accomplish the task that you are asking it to accomplish. Does that make sense?
Yeah, and that's amazing, because this makes it so much easier for everybody to get to meaningful results and meaningful conversations from a this is a chatbot like system, but any other system like it's always interesting to see, okay, who is understanding the domain, who is understanding the database, and this is not necessarily the same person, but in this case, somebody who can, again, the beauty of the graph, we can say, hey, I know what I want, this is my query, and then somebody who is the database expert who has written a couple of Cypher queries can wrap it up into a Cypher query and put it in there, and then you have the access to it, and you don't have to make your data available somewhere.
There's so many benefits to this, because we can, here I didn't work too much on the presentation, as you see, and maybe the experience that you get is a response like this one, but you can be very granular and say, okay, this information actually I've retrieved using that particular tool. So I could actually trace back and attribute my answers to, this is the source that I'm using. And in some cases, if I use tool 1 or tool 2, think of these tools as maybe connecting to different types of databases and maybe APIs. So you can specify where each bit of information comes from and also make that evolve over time. So think of, maybe there's bits that my agent is not able to answer at this point. Like, if I ask a question about something random, it might say, hey, I don't have an answer for that. Maybe I can go to my database and say, okay, I'm going to create a new tool for that. And you get a new tool, and you can trace the usage of tools. Another thing that you could do is maybe track the popularity. How often are tools used? Maybe, one that's never been used, you can, remove it eventually, and you can refine them over time. So you're kind of moving, this dynamic aspect to your database, which is the same idea, again, conceptually, that we use in RAG. We want to move as much as the logic to the database, because that makes it more dynamic, more powerful, and reduces the complexity of our code, makes it more generic. So lots of benefits to this, and I hope people finds it useful. And I don't know, are there any questions in the chat?
I just said, you always say, if you talk about agentic system or tool-based or function-based systems, say, okay, everybody starts kind of with this chatbot thing, but you have to think a little bit about, okay, what is the next step? What do you do? How do you pass on your information? How do you follow through a little bit? And if you think of what you just showed, manipulating the data more, passing on information, maybe a couple of tool usages become certain values are calculated, certain values are passed on to added to as properties to nodes and relationships. Or maybe you think about, okay, I have now this or that query has been running a lot of time, so obviously there is demand for that. Maybe you give it a certain similarity score to a certain question type, or maybe you add, okay, there's a community here that builds up for certain types of scenarios. We add additional values, add additional scoring to it, and that value then enriches all of the whole application you're running on, and you're basing this on this.
Right.
This tool scenario becomes even richer and better over time. So it's
absolutely.
it's
I
an
was
interesting aspect.
thinking of yet another even more meta, which is what if
Today
you
we are on fire.
yeah, exactly. What if you explore the ontology, explore the schema of your graph, and try to discover tools and say, hey, you might want to, the ones that I've defined manually, I could have discovered and say, hey, there's a connection between artist, artwork, and topic. If you follow that path, you get. I mean, I'm sure I haven't tried, and maybe that's an idea for the next session. What if we get the LLM to explore our schema, our ontology, and try to come up with meaningful patterns and ways to explore the database, and provide us with a list of tools that could be potentially useful? And then instead of me creating them, what I do is I curate them. I look at them and say, well, okay, that's rubbish, that's good, that's and that you could get that as well. So that's many kind of was possible next steps from this session. I think it's a pretty interesting one. I hope we didn't disappoint Tomasz with the title and he watches that. I'll check with him.
Yeah, no, I hope not. I don't think so. We have a couple of questions, so maybe we'll dive into those before we close the session. There's a longer comment / question, I guess, from David. I haven't read it yet, so I need to read it at the moment. So I'll think we do this live. So let's see how that goes. He says, in terms of how the LLM chooses which tool to use, does the LLM choose the tool based on the tool name, i.e. function name, or the tool code, which is in this case a cipher query? Can't be the tool comment describing it, since the in-graph node annotations does not seem to contain something equivalent to a function description comment. So yeah, okay.
It is actually the comment. I mean, at least based on what I've read in documentation for LangChain, and in here that's a very interesting point that David raises, because there's, I mean, in this case we're kind of, like I was describing before, providing the LLM with functions with the description, which we are effectively passing when we define a tool. I mean, when you have a chance to check the code, you'll see that the description is a critical element. And actually, in the LangChain documentation, it indicates that providing with the rich description is very, very important for the LLM to make good choices. But you are entirely delegating to the LLM the decision of using one or the other in this case. Now, there's a different approach to that, which is kind of more deterministic agents. And you probably remember in one of the episodes that we use LangGraph, which is another feature in LangChain, where we can define workflows and say, well, for this task, and that particular task back then was, I believe, the extraction of an entity relationship, well, for the extraction of a graph model out of a denormalized data set from Kaggle. So it would go and explore the headers, all the column names, and say, well, that this set of columns seem to be describing a customer. This one is a product definition. This is a location. And then it kind of came up with that. And then we had another step where someone was kind of criticizing the acting as a critic of the model and say, wait, what about extracting these as a separate entity instead of having it as a... So in that case, we define a clear workflow, and that's what LangGraph does. And that's a type of agent where it's very deterministic, and you have the tools, but you specify how they are meant to be used. And there's, like I say, it's a graph that describes that behavior. In this case, it's just a loose set of tools that the LLM will dynamically and based on its own choice use depending on, and to your point, yes, it's based on the description here.
Yeah. Okay. Another question, I think that's what I was hinting at a little bit, is coming from Ricardo. Have you thought about using tools not just to query data but also to modify data?
Absolutely.
I think that's
I think that's a good part of
yeah.
Probably more in a more controlled and deterministic type of workflows. For example, let's say you want to create an agent that will I mean, it's a bit brave of you if you want to provide your credit card details, but it could book a holiday for you. I was traveling to Copenhagen today. I could have ask my agent, okay, look around which are the best, low cost or the better timing or the best airports based on my location from London to Copenhagen. And based on that, go and make a booking. And, of course, the tool could be used to invoke an API and book your flight, or maybe something less risky. But yeah, absolutely. So tools are meant to be both ways for the agent to interact in read or write mode. That's actually one of the key features of an agent, is the ability to interact with in the environment in a kind of sort of sensor actuator sort of way.
Yeah.
So, yeah.
And then
absolutely.
a good example is I had this guest a couple of weeks ago on Neo4j Live, who talks about the tool they developed called Bundesflow, and he said what he's doing is he is pairing questions with answers from this chatbot, but he is assessing, and he has this little feedback mechanism that people can give a thumbs up or thumbs down if they liked the answer. So if people give, after a threshold of a couple of people answering a similar question, going to the same kind of answer, then if enough people give it a thumbs up, he's kind of like storing a relationship or adding a relationship, saying, okay, this is a good pair of question and answer. So feed this back. So in essence, he's creating a new relationship between the vector to the question with the answer, and by that enriching the data set. So this could be another idea to think about it.
Yeah. Actually, I'm thinking it from the point of view of kind of rating the quality of the tools. I mean, because we know at each point which tool was used. If we systematically see a correlation between dissatisfied users and a particular tool being used, we might say, hey, that's a dodgy one. Maybe that's one that we should be reviewing, or maybe having a look at. So, very good point.
Yeah, absolutely. Yeah. Super. Next question from Cameron. Cameron asks, in case of multiple tools for the same node, how best could one manage their execution sequence?
Yeah, again, if you want to take control over the sequence and have that being deterministic or based on a well-defined flow, then I would recommend something like LangGraph. In this case, you're kind of delegating it to the LLM to figure out what's the best sequence of steps that it decides to implement. So, yeah.
And then more, I guess, a comment and a question from Lokesh. Lokesh says, the concept displayed here looks similar to defining a semantic layer for SQL queries. LLMs can use this for query generation.
Let me think. I mean, the way I understand a semantic layer for SQL queries, I mean, I see it more. It could for certain interpretation. It could be. I mean, to me, a semantic layer is more like a mapping between the entities in the in the domain represented by the table, the collection of tables in your relational database, and a more sort of conceptual representation like an ontology. And but yeah, that's it's a way of capturing declaratively some meaning and then making use of it dynamically. And so from that point of view, yes, there's some analogy.
Cool. And then maybe to close it for today, from John, another comment, more likely than a question. Tooling calling with a dynamic graph ontology becomes more powerful if it is a shared graph. Don't know exactly what you mean by shared graph.
Yeah, I mean, you have to take into account a bunch of constraints here, because think of, I mean, actually, if you saw what I did, I mean, my ontology, my tool annotations of my ontology was living in the same graph as my data, which is maybe one approach, because like this, you unify access control. And but again, yes, I don't know if what you mean is that it should be a collaborative graph where multiple people can contribute tools. But
maybe.
It could be, I mean, yes, I was thinking of actually keeping the ontology and the tool definitions in a separate graph and query one in my ontology graph, in my meta graph, if you want, and then having my data in a separate one. That would be entirely possible. But regarding collaborative, definitely it's something that you could do, and you can have, I didn't include it in my ontology. I just defined a tool, but you could associate with each tool who creates that, and whether that person has the right to do it, and whether, if there's some kind of workflow even there, like someone has to approve it, and or some form of collaboration. Maybe that's what John is describing. But yes, that we probably showed today the most basic elements needed to do this dynamic definition, but yes, you can enrich that in many different ways.
Yeah, you can do this becomes we can do this is John's addition. So yeah, I guess, yeah, I mean, if like what I meant also earlier is if somebody who understands the graph and can provide these tools, then it makes it more accessible to everyone and is a bit more approachable, I would say, for people outside of diehard cipher experts. I would say that's another maybe another look into it. Super, cool. Yeah, I think that leads us well to the end of this episode. Again, as usual, we have all the comments. All the GitHub repos on GitHub. All the repos are on GitHub available for each episode. So if you want to look at what Jesus had done today, presented today, you can look at that. Will be available in a couple of days, and you can check that out and see also for all the previous episodes, ongoing meta. Everything is available. Next episode is going to be next month, but in the meantime, I'll do more things. So the next Neo4j live stream is actually going to be on the 12th of March. So this is when our colleague Michael Hunger, together with Curtis van Kent from Google, will talk about, and that's a very fitting topic, building AI agents with Google's Gen AI toolbox, which has just been released. So that's happening next Wednesday, next Wednesday, 12th of March. So if you want to join that, tune in. And other than that, as usual, all the great material available to you. Neo4j Graph Academy, if you want to learn more around Neo4j, and go to neo4j.com/developer for all things on our developer hub, community forums, Discord server, as well as all the documentations around Neo4j and much more. And yeah, thank you very much, Jesus, for today, for the great demo and interesting presentation. I think it's a good food for thought. I think everybody, if you build as always, again, if you build something like it, if you have an idea and you had kind of like were inspired by going meta, let us know. It would always be interesting to see what you are doing with this as a project or as something you're developing.
Cool. Yeah, my pleasure. I was actually browsing a little bit through the question, and just a very quick one, Alex, if you allow me. There's this comment by Gudrun there, where she talks about the difference between graph databases and knowledge graphs. I'd love to spend time in the I don't want to open a new conversation, but yes, I understand a knowledge graph is a logical artifact that you can build on a graph database like Neo4j and in other platforms, like we've talked for many months and weeks here. So there's many ways to integrate those. I showed today how to use an ontology so that regardless of your choice of platform, whether it's a property graph like Neo4j or a triple store, which is probably what you're thinking, you can decide to have data or enrich it with metadata, which is what we did today. And the same you can do it in an RDF store. But please do reach out. I'd love to continue the conversation. I don't necessarily agree with your thought there, but I think we've shown over time how this enrichment with semantics can be done in a graph database like Neo4j. So I leave you with that thought, and with that, thank you very much, and see you next time, Alex.
Yeah, thank you very much, Jesus. See you, everybody. Take care, and yeah, until next time. Bye-bye.